members, Rosnita, Nur Aina Syafiqah and Nurul Alia Farhana. So here our main objective, there are 4 points. First one, to understand the concept of logical implication. Third, to define logical implication using statement and symbol. Third, to construct and use truth table for logical implication. And lastly, to apply logical implication in solving simple examples.
Implication is a type of relationship between two statements or sentences. The second statement is a logically consequence of first statement, which it is called hypothesis. Logical implication is defined as if A and B are two logical expressions and if A implies B is tautology, which means the conclusion is all true. We say that A logically implies B. We use the arrow to the right to represent it is logically implies. Meanwhile, that the arrow has a cross, it is represent not logically implies. This truth table is used for proof conclusion as tautology. If all the conclusions are true, the statement is logically implies. For example, this truth table each row show one possible case for P, Q, and R. We check the implication row by row, but the logical conclusion is based on the entire truth table, not just one row.
Next, let's look at example 1. Here we are going to show you how to answer the question. This expression is taken from exercise book and has been modified. First step, we need to determine whether the following expression are logically implies or not. How do we check? We use truth table. By comparing the truth value, we can clearly check whether the implication is always true or not. So here we have two statements, which is R and S. For R, we used to write true, true, false, false, and for S, we write true, false, true, false. Next, we have R implies S, which is R the hypothesis and S is the conclusion. And we got true, false, true, true. Next column, we separate it for A, which is R and in bracket R implies S. We got true, false, false, false. Next column, we have not R, false, false, true, true. Next column, not R or S, true, false, true, true. And for the another column of B, R and in bracket not R or S, true, false, false, false. The final answer, we got A plus B, which is in bracket R and in bracket R implies S in bracket and close bracket implies R and it open bracket not R or S close bracket, and the answer we got true, 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 which is tautology. Since the answer is tautology, so this expression is logically implies.
For example 2, here is our expression. It looks complex, but it's just saying if P implies Q and Q implies R, then P must imply R. To prove this is always true, we need an 8-row truth table because we have 3 variables, P, Q, and R. First, we list all 8 combinations of true and false for our variables. Next, we solve the individual implication. Remember, P implies Q is only false if P is true but Q is false. We do the same for Q implies R. Now, we combine them using AND. This represents our complete premise. It's only true when both links in our chain are solid. Finally, we test the whole implication. Look at the result. Even when the premises are false, the logical structure holds. Because every single row result in true, we have successfully proven a tautology. This means the argument is logically invisible. If your steps are connected, your conclusion is guaranteed.
Now I will explain example 3. This slide presents the truth table used to test the validity of the logical statement. Not Q and P implies Q, logically not P. First, we start by list of possible combination of true value for the proposition P and Q. Since its proposition can be either true or false, there are 4 possible combinations in total. Next, we evaluate the negation P and Q. The negation is simply reverse the true value of the original proposition. If a statement is true, its negation is false, and if it is false, its negation is true. After that, we calculate the condition statement P implies Q. The implication is only false when P is true and Q is false. In all other cases, the implication is true. Then we combine the not Q and P implies Q using the AND operator to form not Q and P implies Q. This compound statement is true only when both components are true at the same time. Otherwise, it is false. Finally, we evaluate the implication not Q and P implies Q, logically not P. For an implication to be false, the antecedent must be true while the consequent is false. However, when we observe the table, we see that whenever the antecedent is true, the conclusion of P is also true. In these cases where the antecedent is false, the implication is automatically true. Because of this, the final column of the table contains only true values. Therefore, based on the truth table, we can conclude that the given statement is always true, which means the argument is logically valid and is classified as a tautology.
For the conclusion, logically imply if it forms a tautology, meaning is it true in all possible cases. When the statement does not form a tautology, the logical implication does not valid. Truth tables are used as symmetrical method to examine all possible true values and to determine whether a statement is a tautology or not. Thank you.
So, here are our reference for 3 examples. For example 1, the expression, we got it from textbook and we modify it. For example 2, we got it from exercises book, page 1 to 7. And lastly, for example 3, we recreate the expression.